Part 2 wants us to find the exact volume when the region is rotated around the x-axis. So we don't need to change the subject or anything. We're rotating around the x-axis, so we're still rotating between 0 and 20. But we're going to need to take away the volume created when this line here rotates around the x-axis too. That's not going to be a problem. You can imagine it's going to be a cylinder. So let's do the same thing we did in part 1 and just find the total volume when we rotate the whole thing, the rectangle and the region, around the x-axis. So to find that out, we need to times the function by pi and square this function. So when we square that function, the root is going to disappear. And this time when we integrate, we're going to have a natural log involved. So it's going to be 3 times the natural log of 4x plus 1 divided by the coefficient of x, which here is 4. And when I substitute 20 in, I'm going to get 3 natural log of 81 over 4, take away 3 natural log 1 over 4. The natural log of 1 is 0, so that disappears, and we have 3 pi ln 81 over 4. That's the whole region, that's the whole solid. We now need to take away what we get when we rotate this line around the x-axis. If you imagine what we'll get a cylinder. With a height of 20 and a radius of root 3 over 9. So rather than working this out as an integral, it's going to be much easier to work it out as just the volume of the cylinder. So we're going to get pi times the radius squared, so root 3 over 9 all squared times by 20. Pi times 3 over 81 times 20, or 60 pi over 81. So we need to take 60 pi over 81 away. Sixty over 81 can just be cancelled down. They've both got a factor of 3 in them, so I could turn that into 20 pi over 27. I could, you don't need to do this, I could take the pi out and get 3 ln 81 over 4, take 20 over 27. This, you can stop here though, this is fine. Do bear in mind that it did ask for it in exact form, so an answer that you've got from your calculator as a decimal won't be any good here.